Hey everybody, Sunny here, and let me tell you, I've seen more foundation fiascos than I can count. Cracks, settling, moisture problems, you name it. It always comes back to that one critical element, the foundation. And trust me, a solid foundation isn't just about concrete and rebar, it's about understanding the ground you're building on and making smart choices every step of the way. That's why we're breaking down the top 10 things you absolutely need to know when it comes to foundations for your civil engineering projects. We're talking soil types, drainage, load distribution, the works. Whether you're building a skyscraper or a bridge, these tips will save you time, money, and a whole lot of headaches down the road. So let's get right to it. When designing and constructing a foundation for a civil engineering project, several critical factors must be considered to ensure the safety, stability, and longevity of the structure. Here are some essential foundation tips. First things first, you've got to know what you're dealing with beneath the surface. That means getting a proper soil test, not just eyeballing it. Different soil types, clay, sand, rock, they all behave differently under pressure. Clay, for example, expands when it gets wet and shrinks when it dries out. That kind of movement can wreak havoc on your foundation if you're not careful. So understanding your soil is job number one. Now that you know your soil, you can choose the right foundation type. Shallow foundations, like your basic slab or crawl space, they work well when you've got good, stable soil, but if you're dealing with weak or unstable soil, you're going to need to go deep. Deep foundations, like piles or caissons, they go way down to reach that solid ground. They're more expensive, but trust me, they're worth it if your soil demands it. Water is a foundation's worst enemy. It can seep in through cracks, cause mold and mildew, and even weaken the structure over time. That's why waterproofing is non-negotiable. And don't forget about drainage. You've got to make sure water flows away from your foundation, not towards it. That means proper grading, gutters, and maybe even a French drain if you need it. Chapter 4. Sharing the load, distribution and settlement. Think of your foundation like a table. If you put all the weight on one leg, it's going to collapse. Same thing with your foundation. You need even load distribution to prevent cracking and settling. And speaking of settling, some settling is normal, but too much can spell disaster. That's where your soil tests and a good structural engineer come in. They'll help you design a foundation that can handle the load and minimize settling. Chapter 5. Beefing it up foundation reinforcement. Concrete is strong, but it's even stronger with a little help from its friend steel reinforcement. Rebar adds tensile strength to your foundation, helping it resist cracking and bending forces. And don't skimp on the foundation depth. Going deeper means more stability, especially in areas with frost heave or seismic activity. Chapter 6. Shaking things up, seismic design for earthquake zones. If you're building in an earthquake-prone area, you need a foundation that can handle the shake, rattle, and roll. That means special design considerations like base isolation, seismic reinforcement, and flexible connections to the structure. Don't mess around with earthquakes. Get a qualified structural engineer involved from day one. Chapter 7. Size matters, foundation, dimensions, and materials. Just like you wouldn't pour a tiny foundation for a massive building, you've got to make sure your foundation is sized correctly for the load it's going to carry. And don't forget about materials. Concrete is the go-to, but there are other options like steel or even timber piles depending on your soil and climate. Remember that clay we talked about? That stuff can expand and contract like nobody's business, putting pressure on your foundation. One solution is to go deep, way down below the frost line with those deep foundations we discussed. Another is to control the moisture content around your foundation with proper drainage and landscaping. Sometimes you get stuck with less than ideal soil conditions, but don't despair. There are ways to improve it. Soil stabilization techniques like compaction, grouting, or even soil replacement can help you create a more stable base for your foundation. Building a foundation isn't a set it and forget it kind of deal. You need to monitor every step of the construction process. Make sure the soil is compacted properly, the rebar is installed correctly, and the concrete is poured to the right specifications. Remember, a little vigilance goes a long way in preventing costly mistakes down the road. So there you have it, your crash course in foundations. Now, I know it seems like a lot, but trust me, taking the time to get it right from the ground up is the best investment you can make. By addressing these factors early in the design and construction process, you can ensure that your foundation will support the structure safely and effectively for the long term. Remember, a solid foundation is the backbone of any successful civil engineering project. Now get out there and build something amazing.